problem with this screen was the box, so it should be much clearer now, much less torturous to look at at the projector. So that's pretty good. So I've went ahead and started recording the lecture. Now, did everybody get the chance? It's nice to see the classroom so full. Did everybody get the chance to watch the videos on the while loops? Fantastic.
Yeah, the 3.
Yeah, it's very short videos, right? Right, but there was a lot of content in there, and again, I think it's more valuable to talk about that. So, to reiterate, while loops are a specific type of loop. They're what we call indefinite loops, meaning we don't know how long they're gonna, run for. So, for instance, say I have like something like this. Let's go ahead and actually boot up idle, right? Right, and this is one from, actually, I think it's one in your textbook. So I'll just grab it and run through it. Right, the textbook also has some nice flow charts in there, which are pretty nice for helping you understand the stuff. Let's see. Yeah. So here we can copy paste this. Right, new. Okay. So in here we'll learn about also another keyword. Let's see. Password input. All right. So let's see. And I think they wanted to do this whole thing as a loop. Let's see, did I get it in? There we go. I think that's the way they had it formatted correctly, because it didn't really copy the indentation that well. Or if it did, I just was terrible at it. So, Yep, I'm just terrible at copying input. There we go. All right, so let's go ahead and save this into Classroom. Intro to Python. All right, so there's one keyword that we shouldn't be familiar with yet, and that's continue, and it's pretty rarely used. So while true, so this is kind of the most basic password login checker ever. Enter your username and password, and they only have one username. So it will ask, the program asks, who are you? And if and we get the name from the input. And if the name is Joe, sorry, if the name isn't Joe, we continue. So, and what does continue do? Well, that means let's stop the current iteration of the loop right there, right, and restart it. So, well, let's see that in action. So, who are you? I am Andrew. And then it just asks me who I am again. Why does it do that? Because what it says, who are you? It grabs my name, and my name isn't Joe, so we go to continue, which continue means just restart the loop, but go on to the next iteration of it, which we'll see in for loops. It just means we just continue on to the next iteration. Now, again, this is a while loop's an indefinite loop. We don't know how long this is gonna last, because we don't know how incompetent I am at following directions, right? So now I'll type in Joe. Hello, Joe. What's the password? It is a fish. So, and then I put in the password, and I'll put in LOL. So now restarts, because we talked the password. It wasn't swordfish, which was the password, and so we continue back at the top. So continue allowed us to stop. We could have done. I mean, logically, there was no difference in us doing this. For the password input, which was to do a continue here. But we didn't need to, because it would restart it anyway. So continue is useful if you want to restart the loop, if you want to get to the end of the loop early. We don't really use it too much. Now the break, as I mentioned, that stops a loop. Then it says access granted. So break stops a loop. And if you've got nested loops, it stops, which is what I want to focus on today after we go with for loops, right? Because that's actually where, so the if statements are where it gets interesting. So if the if statements, the way we're using them with modular arithmetic and the year stuff for the Pope program, that's where the if statements kind of become interesting. Now over here, when we use nested loops, that's also where we're going to become, where it's going to start getting interesting. So we're going to use for loops to do a bit more ASCII art, some really bad ASCII art to begin with, and then you'll see where we go from there. But back to what I was saying, break statements break out of the loop that it's in. So if you've got a while inside a while, it's only going to break out of the innermost while. Now, because of that, and sometimes it's easy to lose your place, I sometimes like to use I like to do this. I like to use flags instead, as they're called. I like to have use a Boolean. So done is equal to false. Right? Are we done with the program? No, we are not. So, right? We just started the program. Of course we're not done with it. Done is false. Right? Instead of doing while true, I like to say while not done. Make sense? While we're not done with the program, keep going with it. So let's go ahead and run this and make sure that I've not created a syntax error. So who am I? Andrew. Joe. Now, of course, this is going to keep running forever because done never gets set to true in this. Right? I've never bothered setting done to true. What I can do, though, is that I can, instead of having a break statement here, actually, it will work because we still have the break statement there. Right? Instead of having a break statement here, what I could do is set done equal to true, right? Instead of having a break statement there. And because the break comes at the end anyway, this is logically consistent. Who are you? Joe. And the password is swordfish. So done is now set to true. So the loop only runs while we're not done, but we are done. Right? And the reason I like this syntax over here, while not done, right, is because even though it sounds a bit, even though you have to flip the logic a bit, it's good as a teaching method because it flips the logic, and so you have to think about it a bit more. But also, it grammatically makes sense. While we are not done, keep doing this, right? Are we done yet? Yes. So that kind of readability goes a long way for programs, I feel. Okay, so one thing that this was, and we used a while loop also to do definite loops earlier. So open, right? We did the count with while, right? We were just doing different counts with the while loop, right? But honestly, while loops really only should be used for indefinite loops. You can use them for definite loops, which is to say loops that we know how long we're going to last. Instead, what we're going to do is use something called the for loop instead for definite loops, for when you want to repeat something a specific number of times, right? So let's look at what a for loop looks like.
So like if you enter your password wrong 3 times?
That would actually, so that we'd probably use a variable for that, but I'm saying if we wanted to repeat something, like specific action 3 times, like counting, we're going to just deal with counting for right now, okay? Counting is the easiest thing for us to do, but if we wanted to do a something like that, like we wanted to throw out a user after 3 tries. Tries is equal to 0. Right. So, yep. So we would do, if the name is not equal to Joe, tries plus equals 1. If password is equal to swordfish, done is equal to true, else tries plus equals 1, right? If you got the username wrong or the password wrong, we're going to increase the tries. And now up here, what we'll do is while the program is not done, yep, or and actually we want both of these conditions to be true, right? We want to stop once one of these conditions right, is no longer true. So while we're not done with the code, and I'll go ahead and make these parentheses just so we put these in parentheses, and tries is less than 3. So now let's go ahead and see. And again, parentheses doesn't hurt here. So long as both of these are true, this will work. Oh, and we need one more thing to do for this. Control C, kill the program. If try, so basically we want to make sure we don't give people access, right? If tries is less than 3, right? If they were able to log in correctly, print access granted. Else, print go away, right? So who are you? And now if I say A, B, C, it will tell me go away because we tried 3 times, right? We incremented, we had 3 wrong tries, which incremented tries to 3. And 3 is not less than 3, so one of these statements was false, so the entire loop stopped, right? And then we went into this block. Make sense? All right, so let's take a look at what a for loop looks like. So for loops are pretty much useful for counting to begin with, for counting. And then as we see, we can use them to iterate through things, which means go through things one step at a time. So the main thing we use for this is something called the range function. Well, it used to be a function in Python 2. Right? If I try printing out a range function in Python 2, it gives me a very different answer than in Python 3. Python 3, it will tell me range from 0 to 10. Doesn't really give me that much. In fact, it doesn't really do that much for me until I learn about lists. But right now, range, just know that it's a special function, and it essentially feeds you one value at a time. But this is the way a for loop works. If I want to print out the numbers 0 through 4, it's quite simple. For x in range 5. So 5 is where I stop, and I don't go into 5, and I don't go beyond it. Print x. 0, 1, 2, 3, 4, 5. So the way range works is that it covers a range of numbers from 0 up to, but not including the number in there. Now you can put multiple arguments into range. We're just dealing with one argument in range right now. Okay, you know, one argument like if range is if we consider range a function, it like f, we're talking like f of x right over here as opposed to f of x, y, z. We're not making it any more complicated than just having one number put in there. So for x in range 5, this x means essentially this is the number that this is the for loop's variable that's going to change with each step of the loop. So at the first iteration of the loop, well, range is the numbers from 0 to 4, 0 up to but not including 5. So 5 different numbers, right? So we have 5 different numbers, 0 through 4. So x's value is 1. So we can say, let's go ahead and say x is plus. And then I'll turn it into a string to concatenate it. X is 0, x is 1, x is 2, x is 3, and then x is 4. Make sense? Basically, it goes over, x now travels over a range of values, right? Now, x only exists for inside this loop. Just like variables created inside a while loop only exist inside the while loop. So, right, if I go over here, variables only exist in the block of code you create them in, and anything that's more inner than them. They don't exist outside of their block. So, for instance, print x. It's, oh, well, never mind then. Works that way in Java. But if I say y is equal to 5, let's see what happens when we do print y. Ooh, So I just told you a lie. That's something you need to remember if you're if you're working in Java. Java destroys stuff at the end of a block of code. So, and Python does not. Yes.
What if you wanted to
destroy it?
No, I was gonna say use negative numbers, but that's it.
Ooh. Well, not sure about the destroying things, but let's go ahead and try a range. So for negative numbers in a range? Mm-hmm. Excellent question. So range can take up to, for right now, we're dealing with just this. I want to re-emphasize this point, by the way, about x's range. So if I put 100 here, right, this will be number 0 to what? 99, up to but not including the number in there, which is 100 different values, right? Okay, so now just like in the slices, there are 3 variables. Now note this uses the same notation as slices do, the same order. A stop, a start, an end, and then they will have a 3rd variable, which slices can also have, which is the step. So let's just go with 2 arguments for right now, just like slices can have only 2. So you can put 1 argument, you can put 2 arguments, or you can put 3 in here. So 0 through 100, okay? Now if I want to do what if I wanted to do a negative range, like a range of negative numbers? Like
-5 to -100?
Nope. Well, let's see if that will work. -5 to -100. Doesn't do anything because because we add 1 each step of the way. So it would be -5, then -4, then -3, -2.
Oh, okay, so right. It would be -100, -5.
Yeah, -100, and it would go up to, but would not include -5. Right? See how it's counting up towards the range? Yes.
If you set the counter variable.
Yep, we'll get there. I want to just focus on this range right over here. So and this leads to some interesting things you can do, right? We can say we can do stuff like this plus let's go ahead and do like this /t plus x. So we can, instead of doing like x is 100, we can do x squared is, right, because we don't have to just say x. X is a variable, and we can change like the function that we use. So we can use x squared. So now these are negative numbers, right? But negative times a negative is a positive number, so we started with -100. -100 times -100 gives us 10,000. And then we get 9801, and it goes down, right? Why is it going down? Well, because the negative numbers are getting smaller. Well, bigger. It gets complicated with negative numbers, right? The value, right? They get closer to 0.
The absolute value.
Yeah, their absolute value gets smaller. They become less negative. All right, so x squared, right? So we can do any kind of range we want over here. So from here we can do 5. We can do 0 to, again, 100 over here. Now to answer your question, there's this 3rd variable, and just like in slices, you can add this 3rd variable as well. So I'm going to go back to just print. I'm going to print x, and I'll print x squared now. Okay, I'll just have I'm not even going to bother having some text here. Actually, if I put 100 and 0, well, it's going to go from 100 up to 0, which doesn't make sense, so it doesn't go anywhere, right? Makes it. I'll go ahead and try that. So first I'm just going to print out the value and then the value squared. Okay. Oh, and I've got to convert the value to a string as well. So here's the number, and then there's the number squared. Now to answer your question, what if I go from 100 to 0, right? It's going to go from 100 up to but not including 0. So we've gone past, so we're starting at 100, so we've already gone past 0, so no need to go any further, right? So that leads us to the next question. What if we want to go from 100 to 0? Well, we can use the counter, which is this third variable over here, which is how we, and -1 will say, now by default, the way it works is that we put a 1 here if we don't put. So, like, for instance, we had one variable to begin with. That was 5. And what this does is that this expands this out to start from 0 and go by 1s, right? So that's 0 through 5. Sorry, 0 through 4, right? Up to, but not including 5. This is called the start, which is the value we want to start at. This is the stop, which means once we hit this value, stop there. Don't proceed to go into this value. Once we hit this value or go past it, stop. And then we have this count, which is how do we want to count there. So for instance, if I switch this to 2s, right, we go 0, 2, 4, then we go up to 6, right, which is past 5. So we stop. Make sense? So now to switch this around to the 100 to 0, let's go ahead and do by -1s. So it starts at 100, and now it's counting down, and it stops once it hits 0. Let's do -3. Right? So it goes 100, 97, 1, 97, 94, 91, and it goes down by 3s until we hit 1. Then it'll go down to -2, which is less than 0, so obviously we want to stop at this point, right? So we can control the range that we want to do this at. So for x in range 0, right? And so here's the arguments, right? For range stop, we go up to this number, or you can say start, stop, and then optionally by a step as well. So 1 to 100 by 6s, print x. Invalid syntax. What did I forget? I forgot to put a colon here. Right? So you can, so this is fairly robust. You can throw variables into here as well, right? I can put like limit is equal to, let's go ahead and say 100 just so that we get the same output. Instead, I can put limit. Now, what I did over there is by making it all caps, I kind of made it like, this is kind of in other programming languages, we typically have keywords to say, don't change this. In Python, we don't really do that too much. Let's see. So, but if we don't. So I can basically put it in comments and say, sorry, I can put in all caps to kind of say, this is a constant, please don't change this throughout the program, right? Like a good example might be maybe going pi is equal to 3.14159. And this is me saying, please don't change pi. It's kind of important that you don't change it to 3, you know. Okay, so, but this works just fine with me putting a variable in there. And you can put a variable anywhere, and it will evaluate into a variable. All right, so this is where typically I find that, so obviously this means that we're not, yes?
Oh, I just was wondering, can you put a variable as the step and have it be changing?
That is a great question. So let's do that with this one. And the answer is yeah, because if you can think about it, you can probably do it. For x in range 0 to 100, right? And let's create a step over here. X is equal to, so, and then let's print x. Not very common, but we can do this. Print right, just so that we know that, so that we have some kind of so that I have some kind of visual indicator where this begins, right? So here, print x in range, and let's start, and we haven't declared a step variable, so let's do step is equal to 1, right? And then what we'll do is that we'll do see, step is equal to step plus 1. So we take what's stored in step, add 1 to it, and then restore that in step. So it will be 1, then 2, and let's see what happens. Can we? No. Even though I'm changing steps, right? Print x, step, step is equal to step plus 1. Even though I've changed step, it's not changing along with me. So no, Python does not allow that. Yes?
I figured out how to separate the instances when you were talking about trying to print y or defining y.
Oh?
Yeah, well, as long as you define the instance, like, if you go outside of that instance and try to print something, a variable from inside the instance.
Oh, from a function?
Yeah.
Yeah. When you're inside a function. Yeah, that's it. So we'll... Okay, that was where it gets weird. That was it. Okay. Sorry, when I'm teaching between two languages, they crisscross sometimes. So I've got sometimes a bit of a hassle to keep them straight. So now let's go ahead and do some, so we can use this to actually do some ASCII art, which is pretty nice. So for printing.py, and this one will probably be one that you're going to reference quite a bit. So let's go ahead and, and see right here. So for x in range, let's go with range 5, right? Just so that I can do this 5 times. Now I don't have to use x, right? I can just simply do this. So I'm going to, actually I'll just print a /. Dots. Dots are easier to count. So, right, I've just printed out 5 dots. I didn't use x at all in this, right? So 1 dot, 2 dot, 1 dot per line, right? So while x is equal to 0, print out a dot. X is equal to 1, print out a dot. X is equal to 2, print out a dot. X is equal to 3, print out a dot. X is equal to 4, print out a dot. X is equal to 5, print out a dot. Well, no, we don't, because once x is equal to 5, we stop, right? Okay, so now we can, but what if I want to do something, what if I want to generate this pattern? Okay. What if I want to generate a pattern that looks like this?
Make it as a variable, or and then every instance you add an extra dot to it, or you multiply that variable.
Yeah. So we can't. Sorry. Yeah, we can multiply the string because Python's awesome like this and makes it trivial as opposed to the way that we do it in Java. But we're also going to do it the way we do in Java. So we can multiply this by x. Now, if you remember, you multiply a string in Python, it just simply says do this a couple times. Ooh, but we didn't get that. Right? We've got, right? Why didn't from 1 to 6, right? There's a lot of different ways to fix it. So what was the problem though? Let's identify the problem for the people who didn't identify it.
What was the question?
Why does this not match what I wanted? Right? I have 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. Here I have 0 dot, 1 dot, 2 dot, 3 dot, 4 dot.
Because in the first instance, x equals 0.
So dot times 0 means no dot, right? X multiplying something by a string means you repeat this x number of times. So we repeat it, So there were a couple suggestions to fix this, which was use the range 1 through 6, somebody said, which will give you 1, 2, 3, 4, 5. Other ways to fix this. X plus 1 instead, so we keep our range of 5. Yep, keep hitting F5. So, and instead we multiply this by x plus 1. So now we're going through the numbers 1 through 5. Okay. Now, in Java, you don't get to multiply by a string. Instead, we're going to use this concept to do what we call nested for loops. So we can put for loops inside of for loops. And this will be, so let's go ahead and just show you. For y in range x. Print ooh, right? But except we don't get to do, let's see, print. So the issue is, of course, that we don't have a print statement in Java. Let's see. So we need to figure out how to print out stuff in a single line first off. Can we do that in Java? Let's see. Sorry, in Python. Print no new line Python. Can we do that? They really don't want you to do that. Ah, here we go. Here we go. So this is going to basic. So let's modify. So end is equal to. See how that works. So this is the way it's going to look in Java. Something like this. It'll look something like this in Java.
What was the flush statement?
The flush, we don't need it right now. We just need this. So let's take a look and digest this. So 1 through 6. Seems like a much more complicated way to do what we just did, and it is. But it's also important for understanding the concept of a for loop right here. So for x in range 1 through 6. So this means x's values are going to be what? They're going to be 1, 2, 3, and 4, and 5. Okay? So now, once we're inside the loop, we have another loop, which you can do, and actually you do get plenty of loops. So for y in range of x. So what is x's value? And this is what people I see trip up students a lot. And the answer is x is a lot of different values. It's one value on one. It's one value once, then it's a different value, then it's a different value, then it's a different value, then it's a different value. X over here is 1 to begin with, though. So we'll just start at 1, right? So for x in range 1 through 6, right, x is going to start out at 1, right? So for y in range 1, so this means from 0 to 1, right? So this means from 0 to 1, not including the 1, so it's just 0. Print a dot, and then we have this weird end statement with a comma. And what this means is that basically this means normally lines end with print statements end with a new line, meaning they move you to the next line automatically, right? When you do a print statement, it automatically moves you to the next line. If I do print end equals nothing, though, which is what I put in there. Well, let's see. Well, it doesn't show it on the console. Print. Let's see. End is equal to haha. It will print 5 haha at the end rather than printing a new line. It puts a haha. So it tells me. So I'm telling it to end the line with not a carriage return, but instead with whatever I just said. And I'm saying not to do anything there. So for y in range x, I'm telling it to print a single dot. So I print a single dot. Then we're done. We print a new line. This prints a blank line to move on to the next line. And then x's range is 2. Sorry, then x is 2 in this one. So for y in range 2. So y's values are now 0 and 1. I keep hitting F1. 0 and 1. So this means this inner loop runs twice. So we print out 2 dots, and then we print out a new line once we're done with the inner loop. This making sense? We run this inner loop 1 time, then we run it 2 times, then we run the inner loop 3 times, then we run the inner loop 4 times, then we run the inner loop 5 times. Right? Does that make so the inner loop runs X number of times. Yes.
Why would you choose to do this?
Because in Java you don't get the option to do this, and also because when we start working with stuff like lists, you'll have to do it like this. But it's much more obvious when it comes to lists. For right now, though, we get to glory in the. So right now, you just need to know that these things exist. For right now, we can glory in the fact, though, that Python allows us to do to do this. Print. Right. Instead, we get the opportunity in Python to do. Print. Let's do with stars this time. Times X. Instead, we can just print it out like that. We don't necessarily need a nested loop to do this. We can also use for loops to do. Now, what's noted is this in keyword, because it seems kind of out of place, right? So the for loop here is, unlike in Python, this is what we call a for each loop. So for each x, so for each number x in the range of 1 through 6, not including the 6. That's kind of the way it reads out. So let's see how this reads out in another kind of way. Let's see, our string s is equal to hello, comma, world. Okay? S is equal to, so let's go ahead. So now we can use a for loop like this. For letter in S. So for letter in S, print letter. So now we run this, and it prints out hello world. So this actually makes plenty of sense. For every letter in the string, we're going to go through each letter and print it out. Yes?
Is letter a variable?
It is a variable.
Is it just one that we don't have to define? It's just a variable?
No, we can call it whatever we want. For globnox in S, right? So that for variable we define right here to go through the loop. So I can call it globnox. I'm sure if there's an alien invaders, that will turn out to be a horribly offensive word. So we can run it, and now globnox is the variable, right? And this for loop is actually extremely powerful, and Python's extremely powerful. So one thing I'd love to do, by the way, is let's go ahead and go to Project Gutenberg. So there's Project Euler, which is good for programming problems, and we're actually going to do the first problem of Project Euler today, because we're finally at the point where we know our language is up. But Project Gutenberg's great. It's got all the so this is the one for the United States. Gutenberg has all the texts that are public domain, out of copyright, that are out of reach of that mouse in his gloved hands. Disney, yes, that Mickey Mouse specifically, because they've lobbied very hard to extend copyright for as long as possible, so that their characters stay out of the public domain for as long as possible.
What about Kimba?
Kimba, is that the lion? Yeah. Well, should have lobbied harder. So here I'm gonna go, but this is great for my old friend Bill here, right? Shakespeare, right? And here is the complete works of William Shakespeare. I like this because it's a fairly big text file. The complete works of William Shakespeare ends up being about 5.6 megabytes, including the headers and to say what this file is. So I'm going to go ahead and download this. So I'm just going to press Control S here, Command S on there. I'm going to just drop it into the directory with everything else. And I'm going to call, just so that we have an easy way of calling this, I'm going to call it Shakespeare. Now, this is getting a bit ahead of ourselves here, but this is but it's just to show you the power of the for loop here. Shakespeare.text. I'll just call it complete because that's easier to spell for you guys. Complete. So now I'm over here in this file over here. So let's see, for printing. So now let's call, so I'm going to call this lots of text, okay? Lots of text, and now we're going to open the file up. Now, in Java, this is a torment a bit. Actually, it's not too much of a torment because with Java, you just do it the same way you do it with a scanner. Most people tell you got to use a file buffer and then a file reader on the file buffer, and then you can use it like that. It's not actually, once you use a scanner, it's not so hard. Yes, in Java, it's a thing for Java. I'm speaking to the couple of students who have registered for both class. In Python, you don't have to worry about it. In Python, to open up a text file, you go open. It's coming, don't worry. So here, yeah, it's a lot of stuff, but the first thing we need to do is just give it the name of the file. Now, because so long as we're in the same directory, in other words, the text file we're working with is in the same directory as the code you're working on, this should work. Complete, we called it complete.txt. And then we put R just so we aren't making sure that Python knows that we want to read from the file, not write to the file, right? So now we've got lots of text. So now watch this, because I was surprised. I tried this out, right, a number of years ago, and this is what made me fall in love with Python, because I didn't think it would work, and it did. For line, let's call this book. So book is equal to open, right? It's a big book. For line in book, print line. And now this will take a while. And it's just reading the file and printing it out line by line, right? Now again, I could have called it globdocs, but the way open works is that it feeds you. The way that reading a file works is that you either read it one of two ways. You read it one character at a time, which is the way it works by default in C, which is a bit annoying. You read it one letter at a time, but Python's like, well, no. Most people, if they want to read something, they read an entire line and then process the line, right? So that's exactly what we're doing there. Yes.
How do you tell it which one to do? Like when you
I'd have to look that up, believe it or not, because I don't use it that often. But we're gonna learn. For this one, though, the default is just line. Again, I could have called this globnox.
But why is the default line in the second one you made, but for the globnox one?
Because it's asking the question of what is this thing composed of. Because open here didn't give me a string, right? It gave me a file, right? Right. If I print book over here, let's see what happens. It says it gave me this weird IO wrapper thing, right? It didn't actually give me the file. It just gave me like a method of reading the file. It gave me a way to read the file using a for loop. And so now I can read that, right? So here I'm reading a string, right? And here I'm extracting the string one line at a time. Now I can do cool things like this, like ask, okay, instead of printing out the string, I can print out how many characters that line is, right? So that's pretty cool. So let's write a quick program and see how many characters are the complete works of Shakespeare is made of. Okay, count is equal to 0, right? We're going to start at 0. Okay. Now printing out a line at a time slows us down, so we're not going to do that. So instead, we're just going to we're going to use variables. Num chars in line is equal to the length of a line, right? That makes sense to everybody. And that's what I like about Python. So long as you define your variables well, it makes grammatical sense, right? Number of lines and characters is equal to length of line. And now we can call this total chars. We can make this emitter total characters. Total chars we want to increase that by num cars in line. Total cars is not defined, right? What was my error? What did I do wrong? Very common mistake here, even for me. I forget. I called this total car. I called this one total cars, right? Right? That happens. I make that mistake. It was totally a new mistake, and I still made it, even after programming for like over a decade. Oh, can't decode. So it was here. Len line. So, ooh. Car map codec can't be defined by position, character map. Ooh, I've never seen that error. So let's go ahead and print len. So let's see what's going on here. So it's going on fine, and I think it just crashed at the end for some reason. And I'm not sure why. I mean, it should be able to keep going no matter what.
Sounded like it found a character it couldn't recognize.
Which is really weird.
Could that be something stopping it in the middle of reading it once?
I mean, let me go ahead and see it over here. CD. So I'm going to run it outside of idle and see what happens. It should go quicker. CD classroom. CD ITP. Python for printing. Oh, wrong one. What's that? Oh, yep. CD classroom. CD Python for yeah, it's a bit quicker here. Yeah, so I'm just gonna stop that. It says can't decode. So I'll have to look at that, but print total cars out here. It says that, let's expand this so I can see it, so I can read it. For line 23 says codex decoded can't decode a specific byte. It maps to undefined. So that sounds like there's an issue with the file I downloaded for some reason, and I'm not sure why. So let's go ahead and can use idle to open that, believe it. So let's stop and say text files, complete.txt. See? So let's just go ahead and delete these lines at the end, which don't do anything, right? Save it and see if that helps. That is very interesting. I'll have to look at the file because it's never done that for me before. Yes?
I got one on mine too.
Yeah. Not sure what's going on there. So what we do is a lot of times copy.
Oh, maybe it's yeah, you were saying earlier.
Unicode, it's using another encoding. You can try changing the encoding to UTF-8, it says. So open file name, use the encoding UTF-8. So let's try that. So remember these, because if you remember when we downloaded it from Gutenberg, it said it's a plain text UTF-8 style file. So perhaps it thought we were just reading an ASCII file because it said .txt on the end. There we go. So it just had to know that was an RTF8 file. And the complete works of Shakespeare has 5,600,094 characters. Plus some change. Right? That's pretty cool. All right. This one? Oh, at the end? Because this one doesn't print a new line, this one will create, because this one prints out each dot. What this this does is that this prints out each dot individually, one dot at a time. And so when we get to the end of the line, we say we actually need to print out a new line. All right. So I think we've been going on for about an hour now. I think that it's perfect time for a break. Then we'll take a very, very small in-class exercise. And then I'll go over some functions, I think. So we're going to, just to make sure you guys got, it's going to be very, very, very small. Okay?